Ladies and gentlemen, welcome aboard the pilot brief.
Welcome to the pilot brief. Today we start with chapter pressure. So, what is atmospheric pressure? The pressure of the atmosphere is the force exerted on the surface of a unit area by the air. This is the unit area, and this is the force exerted by the atmosphere. This is called atmospheric pressure. When the air is at rest, the pressure exerted is called static pressure. Means when this aircraft is not moving, then it has a static pressure. Then this aircraft experiences a static pressure. When this same aircraft is moving, this experiences static plus dynamic pressure. Means dynamic pressure is due to motion and static pressure remains always there. The air is held to earth by gravitational force. Like this, suppose this is earth here and this is air. Air is held by gravity. Means air is denser below, then it's get less, then more less, then more less. It's like that. Pressure decreases with height. As we gain altitude or as we go higher, our pressure decreases. See, increase in altitude, number of air molecule decreases. So pressure also decreases. The pressure is the measurement with aneroid barometer, measured with aneroid barometer or mercuric barometer. Unit of pressure is hectopascal or inches of mercury. This is our altimeter, which is also called barometric altimeter. Pressure change with height. The rate at which pressure changes is not constant. 1 hectopascal represent as much larger change in height at higher altitude that it does at sea level. That means at MSL, means mean sea level. At mean sea level, height change per 1 hectopascal means pressure drops 1 hectopascal when we climb 27 feet at MSL. At 20,000 feet, pressure drops 1 hectopascal when we climb 15 feet. Above 40,000 feet, pressure drops 1 hectopascal when we climb 100 feet. Pressure and altitude correlation. This table is important. There are many questions from this table. Just remember this table. Suppose at 850 hectopascals, altitude is 5,000. It's ISA conditions. Always. At 700 it's 10,000, at 400 it's 24,000, at 300 it's 30,000, and at 50 it's 68,000. Diurnal variation of pressure. Maximum pressure is at 1000 hours and then 2200 hours. You can remember it like 10 a.m., 10 p.m. Minimum pressure is at 0400 hours and 1600. So this is the most important part of pressure chapter. At 5,000 feet, we have 850 hectopascal. In normal conditions, 850 hectopascal is here. It is a cool layer, cool air or cold layer, whatever. This is warm air. So in low pressure conditions, our 850 hectopascal goes and compresses below, where actual case where it's a 700 hectopascal, but when we are in low pressure and cold air, here it's 850 hectopascal. And it goes opposite in warm air and high pressure system. Actual 850 is here only when there is ISA conditions, but when it's ISA plus or ISA plus here also, then 850 bulges up, where actually it might be 900 hectopascal, but due to warm air and high pressure, it's 850 hectopascal here. So this is the important part of the chapter. When you are coming from high pressure to low pressure, then your altimeter will read high. When you are going from low pressure to high pressure, then your altimeter will read low. Many of us get confused in this. So now what happened? Your altimeter will overread, means it show that you are higher than actual. But you are actually low. Now, why does it happen? Because in cold air, pressure levels are closer together. As I told you, you can see here, pressure levels are closer together. So when you move into low pressure, when you going from high to low, or colder regions, same with the temperature, your altitude reference shifted down, and you finally overread or you are higher. Here you can see in cold air your pressure and temperature, your isobars are closer to each other, and in warm your isobars are far to each other. Pressure laps traded steeper in cold air than warm air. You can see here it will be steeper in cold air. Pressure at a height is less in cold air than warm air. Pressure at a surface is more in cold air. In warm air, surface pressure bulges up. You can see this surface pressure bulges up. It gets bulged up. Altimeter will show more height in cold air. Here, altimeter will show more height because at this point there is actually 800 mercury, but when you are in cold air, it's actually 600 of mercury. You can see here. So it will show more altitude. So this is the dangerous condition when you're going from high to low, and it shows you are high but you are actually low. So there might be any terrain or something. So it's a dangerous condition. Pressure gets a half at 18,000 feet. Now let's start one of the most important topic in altimetry, Q codes and different vertical references. First we start with QFE, actual aerodrome pressure. that used to indicate height. When you set QFE on your altimeter, it will show height. Suppose you are flying here, it will show your height from the ground, which is the vertical distance above the airfield. This is the vertical distance above the airfield. This is your airfield. This shows your height, which vertical distance. That is why when the aircraft is on the ground, on the runway, the altimeter will read 0. So QFE is equals to height, airfield reference basically. Now next we have QNH, station level pressure reduced to mean sea level pressure. Assuming ISA conditions, it is used to indicate elevation and altitude. QNH, when you set QNH on an altimeter, it will indicate, when you set QNH, mean sea level conditions, it will indicate altitude. You are flying here, it will indicate your altitude from mean sea level. Vertical distance, this means your vertical distance from mean sea level. So basically QNH gives you altitude. And if you see your airfield from MSL, it will give you elevation of the airfield from that MSL. Now let's come to QNE, standard pressure setting 1013.25 hectopascal or 29.92 inches of mercury from the sea surface. This is used when flying above the transition altitude. When set, the altimeter will read flight level, not altitude. After the transition altitude, we say flight level because it is standard for all the aircrafts, all the around the world. So QNE is flight level, standard pressure reference. So let's summarize it. QFE So let's summarize it. QFE, when your aircraft is at aerodrome, then it's read 0. When your aircraft is flying and your altimeter is set to QFE, then it gives height. When your altimeter is set to QNH and you are at ground, then it's elevation, basically your airport elevation from MSL. And when you are flying, then it's altitude. When altimeter is set to QNE, it gives you pressure altitude when you are at ground. And when you are flying, it gives you flight level. These are the basic definition: height, vertical distance from the ground; altitude, vertical distance from the mean sea level; elevation, vertical distance of a fixed point above the MSL. Here we can say a fixed point is airport. Temperature effect on pressure. Pressure fall more rapidly in cold air as cold air is heavier. Pressure falls slowly and gradually in warm air. Over the same height, pressure in cold air will be less compared to warm air. You have already seen in this diagram. This is a cold air, this is a warm air. Pressure decreases rapidly here. So, pressure tendency, change in atmospheric pressure in a particular place in a given time is called pressure tendency. Pressure gradient, rate of change of pressure with respect to distance. Its formula: pressure difference two places like A and B divided by distance between the places. For example, A has a pressure of 1010 hectopascal, B has a pressure of 1000 hectopascal. The distance is 100 miles. So pressure gradient is calculated as 1010 minus 1000. It is a difference, then it will come as 10 divided by 100. So it gives 10 hectopascal per 100 miles, or you can say 1 hectopascal per 10 miles. Pressure gradient effect. First effect, it affects on wind speed. Steeper the pressure gradient, stronger will be the winds. Isobar positions. When pressure gradient is steeper, isobars are closely packed and wind speed is stronger. Means the steeper this value will get, wind speed will be more stronger. And this will give you a isobar positions. This is a line of isobars. Isobars are the line of equal pressure tendency. So it will get steeper and wind will get more stronger. So this is a basic relation. You can learn it, or you can just find. This is a basic relation. You can learn it, or if you have a great theoretical knowledge, then you don't have to learn it. It's a basic thing. If you understand all the above thing, you will get it easily. As the temperature increase, our true altitude increase and QNH decreases. So in this picture you can see this is an ISA condition and your true altitude is equal to indicated altitude. But if the temperature increases, your true altitude increases. If the temperature decreases, your true altitude decreases than indicated altitude. When QNH gives you altitude, QNE gives you flight level. When temperature is more, then QNE will be more. Pressure is inversely proportional to temperature and inversely proportional to altitude. So there is a basic relationship between QFF and QNH. The relationship depends on whether the station is above the mean sea level condition or the temperature deviation from ISA. So above means here above means plus, below means minus. So when your aerodrome is above and your temperature is more, QNH will be more. When your station is below and QNH is more, then QFF will be more. When your station is below and temperature is lower than ISA, then QNH is more. So here it's simple. When you have the same signs in both, like your aerodrome is above MSL and your temperature is more than ISA, or your aerodrome is below MSL and your temperature is below ISA, then QNH will be more always, and it's opposite. This is the formula for true altitude altitude on QNH or pressure altitude plus either deviation into 4 into pressure altitude divided by 1000. You will get your true altitude. So let's start with pressure system. Isobars, lines joining equal pressure. It's on a synoptic chart from pressure pattern, which is represented as low, which is also called depression or cyclone, high, anticyclone, trough of low, and ridge of low, and cause. We will study all these below. So, first was low, slow. Isobars here are closely packed. This is a low point. Here pressure is low. Here pressure is high. Air flow from high to low. These are the pressure. These are the line of equal pressure. Means isobars. This is a trough of low. The line extended from low, which has highest low. These are ridges. The line extended from highs. This is col, which is a sandwich between high and low. So let's start with low pressure. It is the area of lowest pressure compared to the surrounding. If the air surface is warm, if the air surface is warmer, the air in contact also becomes warmer through condensation. This warmer air is less dense and lighter, causing it to rise up. As air rising ascent, it cools adiabatically. Eventually, an altitude is reached where the air becomes cold again and cause diversion and spread out. Because of air rise and diverge, the force exerted per unit area column air is reduced. Means, if there is a land, air rises here, get cold, there is an empty space. So from anywhere, suppose from this is a place B, this is a place A. We have warmer air here, then this place. So this warm air will replace that air and this cold air will be remain here. Low is an area of low pressure enclosed with concentric isobars. Concentric isobars means if this is a low pressure area, isobar, isobars. These three lines are isobar. Line of equal pressure. These lines have different pressures, but these all the areas that have these from which these lines are going on have equal pressure. At low, air converges. At low altitude, ascent and diverge at high altitude. I will explain you in this picture full process. As per Bivall's law, in northern hemisphere, air always moves from low in an anti-clockwise direction cyclone. A secondary low move around a primary low is in clockwise direction and it is more turbulent. So it's a formation of low. If the earth's surface is warmer, the air in contact becomes also warmer. So earth's surface is warmer here. So earth's surface is warmer here. So air gets warmer and it rises up. As it rises at any altitude, it gets cooled. Then it cooled and diverge. So there is a empty place here and it gets a low pressure. If it diverges, there is no air here, no? It's already gone up. So it creates a low pressure. So summaries: warm air rise, cools and diverge. Surface pressure decrease and a low is formed. A low is an area of low pressure by a concentric circles. As I told you, this is a low and these are the concentric circles of different pressure. Like its pressure is 1004, it's 1008, it's 996. At low, air converges. At low, you can see air gets converge. It gets converge here. Then air ascends, means it go up. Then diverge at any altitude. Motion of air around a low. As per Biovelet's law, in northern hemisphere, air always move around a low in anti-clockwise direction. This is a low, so air is moving in anti-clockwise direction. And it's called cyclone. Remember this, it's in northern hemisphere, and everything that is in northern hemisphere is opposite in southern hemisphere. A secondary low will have opposite effect. It's a main low, and secondary low will be outside of us. If it's in northern hemisphere, so the low will have a anticyclonic pattern here, and secondary low will have cyclonic pattern. There are two main reasons of depression. Depression means low. Thermal and frontal. Thermal depression is caused by sun heating and rise of hot and moisture, as I told you earlier in above. Over land in summer, over warm subtropical areas. Frontal depression form in the temperate latitudes when warm air moisture meets the cold polar air mass. These large-scale depressions generally found in northern hemisphere, northern Atlantic area, or Greenland or Iceland. Here, see, here's a warm land. Air converges here and also ascends. It's go upwards, and there it cold and diverges. Characteristics of low pressure area. In low, air ascends means it rise. In low, it converges at the surface and diverges at a higher level. Visibility is good except precipitation. If it's raining, then visibility will be not good. It indicates an unstable atmosphere. As I explained you, air will move up, so from any other place air will come here, so it creates an unstable atmosphere. Air will blow in anti-clockwise around a low in other hemisphere. Suppose it's another hemisphere, then its flow anticyclone. Weather associated with a low, there will be clouds. Weather associated with a low or cyclone. Clouds 8 by 8 octaves, sky will be fully covered. Visibility good except precipitation. Showery precipitation, heavy rainfall depending on the severity of a low or severity of the system. Winds will be strong, and weather will thunderstorm, turbulence, CB, clouds also. Means in low, all the bad things happen. So their classification of low, if the speed is less than 17 knots, then it's low. If speed is between 17 to 27 knots, then it's depression. 28 to 33 knots, then deep depression. Cyclone is 34 to 47, 48 to 63 is severe cyclone. The low pressure area, warm moisture converge. Remember this It's the third time I'm explaining this. It is the third time this picture is explaining the same thing. This is a low pressure. Air gets converge, and it rise. At any altitude, it cool down and diverge and form clouds. It's 8 by 8 octaves. So trough of low. These are the isobars. It's like a tongue-like shape outward extended from isobar from an area of low pressure. The area is associated with line of spools. Means this area from all the low pressure will have the lowest pressure. High pressure system. This is the region of relatively high pressure, apparently as a roughly circular concentric isobars. Highest pressure is at the center. It also refers as high. Isobars are generally more wider than depression. In depression or low, we have closer isobars. In high, we have far isobars. Airflow out of the center of the high pressure towards the area of low pressure. This is called divergence. Airflow high to low. To replace the diverging air descends. This is called subsidence. As I told you, if the air from high to high pressure is going to low pressure, so there will be an empty space here. So air above this will descend and capture this place. And this air is already above. Made with the winds, it will flow here or here, depends on the winds. Air circulates clockwise in high northern hemisphere and counterclockwise in the southern hemisphere. You can see here high pressure system. It's a high. Here air descends and diverges and it moves towards low. It's in northern hemisphere we have a circular pattern. In southern hemisphere we have clockwise. In northern hemisphere we have clockwise circulation, and southern hemisphere we have anti-clockwise. So weather associated with high pressure is cloud, none cloud, no cloud will be there. Visibility haze or fog in warm months. Visibility will not that good as in low pressure system. Precipitation no. Wind will be light and sky will be clear. So high pressure system is characterized by sinking air, divergence clockwise, widely spaced isobars, and fair and stable weather. Cloud none, visibility haze or anticyclone none, light clear sky. So these are the ridges. They are the extension from high pressure system. They look like U shape and elongate high. It associates with fair weather. Coals, a sandwich between two highs and two lows. Two lows and two highs form a col. It's a sandwich. This area of uniform pressure, it basically have uniform pressure all over this point. It have winter fog or summer storms. So it's basically a small it's basically a small recap. It's a low pressure area, air converges, rises up, ascends, get cold, form clouds, have rain, Low pressure area have cyclone closely packs isobar and in anti-clockwise direction. It will go like this, it will go like this. High pressure, we have anti-clockwise. In high pressure, cold, we have hot air above. It descends and then diverges and move towards low. High pressure, anticyclone, isobars are distant and clockwise. So it's a basic, or I can say helpful topic. When you're flying from high to low, I have told you earlier, when we are flying from high to low, our altimeter will read high. But we have also a drift here. The direction might change when we are going from high to low. So when we are going high, high is clockwise. As here I said, it's a clockwise line going from clockwise to low pressure, and in low pressure it's anti-clockwise. So if we are flying from high to low, this is our aircraft, this is left, this is right. So we will experience a starboard drift. Starboard means right drift, and winds are from left. Left has port. Winds are from port. So there is a trick from low is left. Means when you are flying towards low, winds are from left and you will have a right drift or starboard. Flying from low to high pressure. High pressure clockwise, low pressure anti-clockwise. So when you are going into the high pressure, you will have winds from your right side, means starboard side, and you will deflect or you will drift to left side, that is your port side. Understand this clearly, the upcoming topics will become much easier for you. Thank you.
If you are serious about aviation or preparing for DGCA, make sure you are following the pilot brief.
Till then, stay ahead and fly safe.